Dear students, start with new chapters, basic algebra and quadratic equations. So you are very familiar with quadratic equations. A quadratic equation is of the form ax squared plus bx plus c equal 0, a not equal to 0. So you know quadratic formula x equal to minus b plus or minus b squared minus 4ac by 2a minus b plus or minus root of d by 2a d equal to root of d equal to b squared minus 4ac. This is called discriminant. D is called discriminant. Nature of roots, it is familiar for you. If d is less than 0, then roots are non-real. Complex roots. If d greater than 0, roots are real and distinct. That is x equal to minus b plus root of d by 2a, x2 equal to minus b minus root of d by 2a. Then ax squared plus bx plus c equal to a into x minus x1 into x minus x2. So the constant into x minus x1 into x minus x2. x1 is one root, x2 is one root. So you can make it a factor as x minus x1 is a factor, another factor is x minus x2. So ax plus bx plus can be written as a into x minus x1 into x minus x2. If d equals 0, then roots are real and equal. In this case, x1 equal to x2 equal to minus b by 2a. So ax squared plus bx plus c equal to a into x minus x1 whole squared. A into x minus x1 the whole squared. That is C. If D is greater than or equal to 0, the roots are real. If D1 and D2 be the discriminants to quadratic equations, then if D1 plus D2 greater than or equal to 0, then at least one of D1 and D2 greater than or equal to 0. If D1 less than 0, then D2 greater than 0, and if D1 greater than 0, then D2 less than 0. If sum of two discriminants D1 plus D2 less than 0, then at least one of D1 and D2 less than 0. If D1 less than 0, then D2 greater than 0, and if D1 greater than 0, then D2 less than 0. If A comma B comma C belongs to Q, so that is the set of rationals, and D is a perfect square, perfect square of a rational number, The roots are rational, and in case it is not a perfect square, the roots are irrational. We know root of 1 equal to 1, root of minus 1 equal to I, that is known as I is known as iota. This is derived from iota. Its meaning imaginary. I means root of minus 1. For two real numbers a and b, with the help of I, we write a plus ib, which is a complex number. The roots are not real, that is complex. You will study in plus 2, but sometimes we will use some places this type of numbers. So that I tell you, a plus ib is known as complex number. A is called real part, b is called imaginary part. A minus ib is conjugate of this complex number, just changing sign in the imaginary part. If a, b, c belongs to R and p plus iq is a root of ax square plus bx plus c equals 0, then the other root must be its conjugate p minus iq. And vice versa. It means that if p minus q is a root, then p plus q is another root. P, q are real numbers and I equal to root of minus 1. If a, b, c belongs to q, that is rationals, and p plus root q is 1 root of ax square plus bx plus c equals 0, then the other roots must be the conjugate p minus root q. So p minus root q is conjugate of p plus root q. Just changing sign in the irrational part. And vice versa. So p is rational root q is a third or irrational. If a equal to 1 and b comma c belongs to I, and the roots of ax square plus bx plus c equals 0 or rational numbers, these roots must be integers. In ax plus bx plus c, if a equal to 1, bc belongs to integers, then surely the roots must be integers. If a plus b plus c equals 0, and a, b, c are rational, one is a root of ax square plus bx plus c equal to 0, then the roots of a, b, c are rational. One is one root, so other root should be rational. The roots are rational. A square plus b square plus c square minus ab minus bc minus ca, that can be written as half into a minus b whole square plus b minus a whole square plus c minus a whole square. Also equal to, this is equal to this one, also equal to minus of a minus b into b minus c plus b minus c into c minus a plus c minus a into a minus b. So a square plus b square plus c square minus ab minus bc minus ca, that is equal to half into a minus whole square plus b minus whole square plus a minus whole square that is also equal to minus of a minus b into b minus c plus b minus into c minus a plus c minus a into a minus b. Five plus 2 root 6 into x square minus 3. 5 minus 2 root 6 into x squared minus 3 equal to 10. If a power f of x plus b power f of x equal to a plus b, then f of x equal to plus or minus 1. So up to this concept, a per f of x, a and b are different value. A per f of x, b per f of x equal to a plus b. F of x equal to plus or minus 1. Here a plus b, 5 plus 2 root 6 plus 5 minus 2 root 6 equal to 10. We get this. Therefore, f of x equal to, which implies f of x equal to plus or minus 1, x square minus 3 equal to plus or minus 1. So x square minus 3 equal to 1, x square minus 3 equal to minus 1, x square equal to 4, x square equal to 2. So x equal to plus or minus 2, x equal to plus or minus root 2. relation between roots and coefficients. If the roots of ax square plus bx plus c equals 0 are real and distinct, and alpha less than beta, then alpha equal to minus p plus root d by 2a, beta equal to b plus root d by 2a. Minus b minus root d by 2a. Here alpha is greater than beta. Sum of the roots s equal to alpha plus beta, that is minus bba product of the roots p, that is alpha into beta equal to c by a difference of the roots t dash, that is alpha minus beta equal to root d, that is discriminant by coefficient of x squared, root of d by coefficient of x squared. Symmetric function of roots. A function of alpha and beta or alpha and beta is said to be symmetric function If it remains unchanged, when alpha and beta are interchanged. Suppose f of alpha comma beta, alpha cubed plus 3 alpha squared beta plus 3 alpha beta square plus beta cubed. F of beta comma alpha, beta cubed 3 beta squared alpha 3 beta alpha square plus alpha cubed. Here alpha and beta are interchanged. You see, f of alpha comma beta equal to f of beta comma alpha. So there is symmetric function. This function is known as, therefore, alpha cubed plus 3 alpha square plus beta 3 alpha beta square plus beta cubed is symmetric function. So alpha square plus beta squared equal to alpha plus beta whole squared minus 2 alpha beta. We know that this is equal to minus b by a whole squared minus 2 c by a. So b square by a squared minus 2c by a. B square minus two ac by a squared. So alpha squared plus beta squared equal to b squared minus 2ac by a squared. Alpha square minus beta squared is nothing but alpha plus beta into alpha minus beta. We know that minus b by a, the difference of the roots we have seen already, root d by a, that is minus b root d by a squared. Alpha cubed plus beta cubed equal to alpha plus beta the whole cubed minus 3 alpha beta into alpha plus beta minus b by a the whole cubed minus 3 into c by a into minus b by a minus b cubed by a cubed plus 3 bc by a squared equal to minus b cubed plus 3abc by a cubed, or minus of b cubed minus 3abc by a cubed. Alpha cubed minus beta cubed. Alpha minus beta whole cubed plus 3 alpha beta into alpha minus beta, that is root d by a whole cubed 3 into c by a into root d by a. So root d into d by a cubed plus 3c root d by a squared. Taking root d in common, d by a cubed plus 3c by a squared. Root d plus 3ac by a cubed. Alpha power 4 plus beta power 4. Alpha square plus beta whole square minus 2 alpha square plus beta squared. The first step, we found alpha square plus beta squared, that is minus b squared minus 2ac by a squared, the whole square minus 2 c square by a squared. So b squared minus 2ac the whole squared by a power 4 minus 2c square by a squared. So b squared minus 2ac the whole squared minus 2a squared c squared divided by a power 4. So this is equal to b power 4 plus 4 a squared c squared minus 4 b squared ac minus 2 a squared c squared divided by a power 4. b power 4 plus 2 a squared c squared minus 4 b squared ac by a power 4. Next, alpha power 4 minus beta power 4, that is alpha square plus beta squared into alpha square minus beta squared. For this, the answer is b square minus 2ac by a squared. For this answer, minus b root d by a. Sorry, a squared. So minus b root d b squared minus 2ac by a power 4. alpha power 5 plus beta power 5 equal to alpha square plus beta squared alpha cubed plus beta cubed minus alpha squared beta squared into alpha plus beta. You apply all the results and you simplify. Minus of b power 5 minus 5a b cubed c plus 5a squared b c squared divided by a power 5. We have found already the results. We know alpha square plus beta squared. You know alpha cubed plus beta cubed. Alpha beta c by a minus b a. Substitute all the results. You will get the results finally. Like that, to get value of alpha power 5 minus beta power 5, alpha square plus beta squared into alpha cubed minus beta cubed plus alpha squared beta squared into alpha minus beta. We substitute all the results. That is b squared minus 2ac by a squared root d into d plus 3ac by a cubed. Here c by a whole squared. Here root d by a alpha minus beta. That is difference of roots. So you can find root d into b power 4 minus 3ac b squared plus 3a squared c squared whole divided by a power 5. After simplifying, you will get this answer. Some basic properties of inequalities. So equality equal sign less than 0, greater than 0, less than, greater than. The inequality signs. Elementary properties of inequalities. If A, B, C are real numbers, such that A is greater than B and B is greater than C, then A is greater than C. A is greater than B, B is greater than C, then A is greater than C. More generally, if A1, A2, etc. An are real numbers such that A1 greater than A2 greater than A3 etc. greater than AN, then A1 is greater than AN. If A comma B are real numbers, then A is greater than B implies A plus is greater than B plus C. For all C belongs to R. Adding, if A is greater than B, adding C on both sides, A plus is greater than B plus C. Also, A greater than B implies A minus is greater than B minus C for all C belongs to R, real numbers. So, property 3, if A and B are two real numbers, then A greater than B implies AC greater than BC and A by C greater than B by C for all C greater than 0, C belongs to R. Also, A greater than B implies AC less than and A by C less than B by C for all C less than 0. C belongs to R. So, if C is positive, AC greater than BC as well A by C greater than B by C. When C is less than 0, AC less than BC as well A by C less than B by C. That means whenever you multiply by negative sign, the inequality will get changed. If you multiply by the negative value, the greater than will become less than. If you multiply the positive quantity, there will be no change in inequality. If A greater than B greater than 0, then 1 by A which is less than, if you take reciprocal, the inequality will get changed. If A1 greater than B1, A2 greater than B2, A3 greater than B3, etc., AN greater than BN, then a1 plus a2 plus etc. an greater than b1 plus b2 plus etc. bn. If a1, a2, a3 etc. an and b1, b2 etc. bn are positive real numbers, such that a1 greater than b1, a2 greater than b2 etc. an greater than bn, then a1, a2 etc. an, the product of those numbers is greater than b1, b2 etc. bn. If a comma b are positive real numbers, such that a less than b, and if n is any positive rational number then a power n less than b power n, a power minus n greater than b power minus n, a power 1 by n less than b power 1 by n. If 0 less than a less than 1 and n is any positive rational number then 0 less than a power n less than 1. If a lies between 0 and 1, a power n also lies between 0 and 1, and obviously a power minus n which is greater than 1. Suppose I take a equal to 1 by 2. A squared, that is 1 by 2 whole squared, 1 by 4 lies between 0 to 1. I take a power minus a equal to minus half, a power minus n, 1 by 2 whole power, I take a power minus 1 or a power minus 2, 1 by 2 whole power minus 2. So 2 power minus 1, that is minus 2, that is 2 squared, that is 4, which is greater than 1. If b greater than 1 and n is any positive rational number, then b power n greater than 1, 0 less than b power minus n less than 1. If 0 a less than 1, mn or positive rational numbers then m greater than n implies a power m less than a power n. M less than n implies a power m greater than a power n. If a greater than 1 and m comma n are positive rational numbers, then m greater than n implies a power m greater than a power n. M less than n implies a power m less than a power n. So you have to go through all the results. Still we are going to see more results, then only we will start solving problems. Thank you.